Hello everyone, welcome back to Understanding Mathematics, and today we're going to be going over some derivatives, specifically the definition of the derivative. Now this is probably the first thing you'd ever learn when you're in your calculus class and you're learning derivatives. Hopefully you already know limits because you need to know limits to do the definition. And surprisingly, the definition of the derivative is one of the hardest parts of learning derivatives. And the reason for that, it's not because it's really difficult to learn conceptually. Conceptually, it's really easy, guys. It's just the slope. And you've done plenty of slope in algebra. You know what slope is, but this definition of the derivative, when you plug in the function, it gets really messy algebraically. And a lot of people that I've helped with in math, their algebra is kind of weak and they don't know what to do when they get stuck. So hopefully you learn some skills in this video that help you get out of those stuck and tough situations. Okay, so let's just dive on in. Find the derivative of the function using the definition of the derivative. Okay, so in order to solve this problem, we need a function, and B, we need to know the definition of the derivative. So we're given it here, y equals x minus 2, all under the square root. Okay, well that's easy enough. Now we need the definition. Well, it's also given. It usually won't be given. I think you're expected to memorize it in most cases, but it's pretty easy to memorize once you've done a couple of homework problems with it, so don't worry too much about that. So the definition is equal to the limit as h approaches 0, f of x plus h minus f of x all over h. This might be kind of confusing for someone who's never seen it, but let's just do an example and it'll make a lot more sense once we just dive into it. Now I will say this, do not take the limit right away because you'll get undefined every time, right? So you need to plug in the function and then you can take the limit. So let's just get into it. We'll rewrite our limit as, oops, I almost put x, I'm so used to it always being x. That's an h this time, h approaches 0, and then f of x plus h. In this situation, it's the square root. It's kind of a long square root. I'll do that. It'll be x plus h minus 2. And this, with this function, that is the equivalent of f of x plus h. And that's all you really do when you see f of x plus h. Just add a plus right next to the x. If the x is under square root, the h is also under square root. If the x is squared, the h is also squared. H and x go hand in hand in the definition of a derivative. Okay? And then minus just the regular function. We'll do x minus 2. And this is all over h. Okay, so now we have it plugged in. Now this is when you use your algebra. Because this right here, this is the derivative of that function. If we take the limit to 0, we'd get the derivative. Unfortunately, we need to do something to get that h out of the denominator because it's going to mess us up. So what we'll do first is we're going to do the conjugate of this radical on top. So we'll multiply everything by x plus h minus 2. And instead of doing a minus, we add. I have an ugly plus. Let me fix that. X minus 2 plus x minus x minus 2. And so we multiply that to the top and the bottom. So what we get is the radicals go away on top, which is what's so cool about this technique. So then we get stuck with x plus h minus 2 minus x, and then it would be negative times negative 2, so you just get plus 2. And then all over, you get this quantity times h at the bottom. So let's just write that in really fast. X plus h minus 2 minus, or plus, sorry, plus x minus 2. So that's where we are right now. And so at this point, if we took the limit, we still have the limit. I didn't write it down, but the limit is still there. If we took the limit to h approaches 0, we would still run into the same problem as before, right? We would get 0 on the denominator. But this top part, the radicals are gone, and we can actually do some canceling out. So we have a positive x and a negative x. Gone. Negative 2, positive 2. Gone. So now we can rewrite this as h, there's just a lone h on top. And h here times this quantity. X plus h minus 2 plus x minus 2. It's a little bit messy, but you get the idea. You should be taking notes and you'll know what these are. And then look at this, our h's cancel. And if you're doing the definition of the derivative right, this should happen every time where you don't have an h on the top and you don't have an h on the bottom. That could cancel everything out. We still have an h on the bottom right here, but it won't cancel anything out if we plug in 0 for it. And that's how you know that you're done algebraically, when you can take the limit and you'll get an answer. So now we take the limit and the h goes away, basically. That last h goes away. So we have a 1 on top, and then we have radical x minus 2 plus radical x minus 2. So we can just make that 2 radical x minus 2. And that's your derivative. That's how you do the definition of the derivative. It's not too hard conceptually, because what's a derivative? It's just a slope. And I'm sure you know that already. It's just a slope. But it's the algebra that gets kind of confusing. Some of you might run into this part here and not know what to do. Like, how do I get this h out of the denominator? You have to do the conjugate. Some people might not have the algebra skills, or maybe you just forgot. You forgot how to do that. And so that's all you do. You do the conjugate, and then you do some algebra, clear some stuff away, and then your h's cancel, hopefully. Alright, let's get into the next example. So unfortunately, very rarely do you just get asked for the derivative. Usually you have to do something with the derivative. This is a good example of something you might be asked to do. So write the equation of the tangent line to the graph at the indicated x value. And the function we're given is y equals 1 over x. And the x value is x equals negative 3. So if you want the equation to the tangent line, you need two things. You need the slope, which is the derivative, and then a point. And so for the point, we already have the x-coordinate, x equals negative 3. So we need to find the y component, and that should be pretty easy. But let's work on the derivative first. And if this is like your first derivative test, usually you'll be asked to do this using the definition of the derivative, which is a pain, I know, but you should still know how to do it. And so since I just taught you how to do the definition of the derivative, I would suggest that you find the derivative of this function here, y equals 1 over x. Pause the video, go and solve it, and then I'll show you the answer, and I'll briefly go through how to solve this. This one should be a little bit simpler than the one I showed you, so hopefully you can figure it out. Alright, go ahead and pause the video, and I'll show you the answer in a sec. Okay, so let's go to the answer. And you should have gotten negative 1 over x squared. And the way to do this is, you have your function y equals 1 over x. You plug in 1 over x plus h here, minus 1 over x, all over h. Well, I don't like having this double fraction, so I want to get rid of it. So I'm going to multiply by the least common denominator, which is x times x plus h. So multiply the top and the bottom by that. At the top, you end up with x minus x plus h. At the bottom, you end up with x times h times x plus h. Or times x plus h, yeah. X times h times x plus h. And then, so what we do here is you try to get rid of your h at the bottom, because remember, this h is going to cancel everything out and ruin everything. So you want to try to get rid of it. Luckily, your x's cancel out on top. You have an x plus x minus x. That cancels out. And that negative makes this h negative. So then you have negative h over x times h times x plus h. And then those h's cancel. And then you take the limit as h approaches 0, and then that gets rid of this h. That h becomes 0, and then you get x times x squared, negative 1 over x squared. Hopefully you got that. Let's go back to this problem. Okay, so now we know the derivative, right? You guys just found it. And the derivative is dy dx, whoa, what just happened? Dy dx is equal to negative 1 over x squared. Now, hopefully you know what a tangent line is, but if you haven't learned what a tangent line is, I can show you very quickly what it is graphically. So the one in red is 1 over x. That's our main function. And then this blue line is the tangent line. So remember we were asked to find the tangent line at x equals negative 3. So it intersects here, negative 3. And we need to find the y-coordinate and the slope of this line, basically, to find the equation. That's all a tangent line is. It's tangent to the function at that point. Okay. So we have the derivative, but we don't have the slope yet. Because I'm sure you know this, the derivative varies based on the point in most functions. So let's find the derivative at x equals negative 3. How do you do that? All you do is plug it in. And you end up with negative 1 over 9. Negative 3 squared, 9. So, boom, now we have the slope done. That's the slope. Now the point's really easy. You may not even need to watch this part if you know how to do it. I'll just do it with you very quickly. Y equals 1 over x. Then you just plug in your x value, negative 3. And there you go. That's your y value, negative 1/3. And then so when you turn this into an equation, I suggest you use point-slope form because you have a point and a slope. This makes the most sense. So what's point-slope form? Y minus y1 equals m is slope, and then x minus x1. And so y1 and x1 is the point. This is our y1, this is our x1, and then this is our m. This is all we use, and then m and x will stay the same. So y plus 1/3. The reason why it's plus is because, minus to minus, right? Equals, our slope is negative 1/9. X minus negative 3, x plus 3. And there you go. That's the equation of the tangent line at x equals 3. I suggest you should practice it again. Try a different coordinate. Do x negative 6 maybe. Something else just to get into the habit of this, because these type of problems are very common on a derivative exam in calculus. And that'll wrap this video up, guys. Thank you so much for watching. Good luck on your exams, and I'll see you next time.